Great. Next up, let's welcome David Abel from Google DeepMind, who's going to be presenting a talk titled Agency is Frame Dependent.
Hear me okay? Yeah, thumbs up. Great. All right. I'm really excited to share this work. This is going with all of these wonderful collaborators spread across Mind and the University of Alberta. The starting point for us comes back to this really lovely book by Herb Simon called The Sciences of the Artificial. It starts this book by saying the science, the task of natural science is to show that the wonderful is not incomprehensible. For me, when I think about the aims of the RLDM community, when we look out at the natural world, it surely makes sense of a wonder that separates something like a rock from something like a cat. Ultimately, what is this distinction? And to me, one of the essential properties that separates these two is that of agency. We just heard from Sabrina about agency. One way of thinking about agency is the capacity to steer goals, steer outcomes for a goal. And when we attribute agency to something like, say, the caterpillar, the main claim of this work is that we are doing so in what we'll call a frame-dependent way. That is, it depends on a reference frame, a set of commitments that allow us to make clean deliberation about the agency of the system. So what do we mean by this? Well, imagine back to a case, maybe a person throwing a ball. In order to measure, say, the velocity of that ball, we have to invoke something like an inertial reference frame that commits us to a particular way of measuring, say, that velocity. So the velocity relative to this person, and imagine it's 3 miles per hour moving away. But of course, according to a slightly different reference frame that's centered on the ball, the person is flying backwards at 3 miles per hour and the ball is stationary. We can imagine invoking further such reference frames involving maybe a bird flying overhead at a different angle, and then recover yet a different velocity. And the story is effectively the same for us when it comes to this concept of agency. That is, in thinking about the agency of something like a caterpillar, we'll invoke the notion of a reference frame, which is a set of commitments that will allow us to be precise about the agency of this caterpillar. And according to this first reference frame, we might find this caterpillar in fact does have agency. But the difficulty is that, according to another reference frame, a different set of commitments, we might find that caterpillar does not. So in order to make this argument a little bit more precise, we'll need to bring on board a definition of agency. Although before I dive into the details of the definition, I'll just flag, for our purposes, we think most reasonable definitions of agency will admit frame dependence. All that contingent on this specific choice of definition. As mentioned, one way to think about this definition is the capacity to steer outcomes toward a goal. This largely comes from a work called Defining Agency by Baron Deering and colleagues. It involves 4 properties. The first of which is that an input-output system that has agency, only an agent, is a thing with a boundary that separates it from its environment. Once you pick that boundary, the thing inside of that boundary must be a cause of its own actions. It's something like a free will property. The third property is that of goal-directedness, namely the system inside that boundary must have a goal or a norm that's regulating its behavior. And the last property is that the system inside that boundary must adapt based on its capable of adapting. So let's take a look at each of these in a little bit more detail. This notion of the boundary, as suggested, is just a way of separating that agent from the rest of the environment. So for instance, in the case of something like an owl, you might imagine drawing a boundary around, say, the feathers of the owl, and making a commitment about the inputs and the outputs the owl is. First steps sort of actions, muscle fiber, something like that. And then once we've chosen that boundary, we can then inspect the other properties. The second one, source of action, as mentioned, is something like a free will property. And in the case of, say, a wrecking ball smashing over a wall, you might ask, where is the interesting source of action, like this in this scene? Perhaps it's not cleanest to think of a wall as choosing to be knocked over, but instead, the wrecking ball is kind of the true source of action in this case, or perhaps individual operating the machinery is causing this wrecking ball to knock this wall over. In the case of goal-directedness, this is, I think, quite at home in this community. Does it mean for an agent to have a goal or no? Perhaps frog jumping between lily pads can be best understood as pursuing some piece of food on the other lily pad. The fourth one actually comes rather than from the Baron Deering work, apart from Reno and Van Dennis work, the intentional stance, and roughly admits to the view that agents have to be able to adapt to their concepts. So one nice example, you can imagine a sunflower that steers its petals toward the sun in order to soak up more energy. It's adapting to the fact that they're going to be more available in some parts of its experience. So these four conditions together comprise our definition of agency. We start from a boundary and then recover these three for the object within that boundary. So using these, we'll then put forward this claim that attributing agency to a system depends on how we commit to each of these four things. So in one classical example, in the agency literature, we can debate about whether a thermostat has agency, as this group did quite heavily throughout this work. And according to one reference frame, we'll need to make some commitments about that thermostat in order to reach a conclusion whether or not it has agency. Similarly, we can imagine a different reference frame reaching a different conclusion about the agency of the thermostat. And we really just embrace the fact there is no objective fact of the matter as to whether or not the thermostat has agency, but rather, according to different reference frames, we'll reach different conclusions. And throughout so far, I've been referring to agency as a Boolean property, but of course, it's quite natural to also think about this as a matter of degree. We're just going to use Boolean as a simplification throughout the work. So this is a main claim, but how exactly do we support this claim? Well, our main argument is to say, in trying to address this question of whether or not a system such as a thermostat has agency, what we have to do is first choose a boundary, as indicated. So with our thermostat, we might pick a particular boundary. Maybe it doesn't include sensors around the room, it's just the little thermostat itself, the inputs and the outputs and so on. And then subject to that boundary, we make commitments about we have to try to determine whether that little thermostat is the source of action, whether it has a meaningful role, and whether it adapts to its process. And according to this definition of agency, the thermostat has agency if and only if all three of these properties are present in the system, with the conjunction of these three. And the difficulty, the reason that we take agency to be very dependent is that all three of these properties are themselves very dependent. There's inherent independence of these three properties into the definition of agency. Okay, so let's have a quick look at why each of these might be thought to be frame dependent. We'll start with the boundary. Really, the boundary is just about allowing us to convince ourselves that we're all talking about the same system. We're all agreeing about what we mean when we refer to owl, caterpillar, or the bird sign. And there's these two really lovely papers that really bring this notion of the boundary to the forefront into the reinforcement learning literature. One is by Nan Zhang in 2017, and another by Haru Tunyan in 2020. And in Gang 2017, they suggest taking a look at the DQ network, suggesting there are many different ways we could draw a boundary that separates the DQ network from its environment. So for instance, you can imagine drawing this boundary prior to downsampling your observations or after. Depending on how you draw that boundary, we'll actually reach pretty different conclusions about things like the value function in this setup. So all this just to say, most cases admit many viable boundaries. Supposing we've now chosen one such boundary, we can then turn to attributing something like a source of action. Does this system inside the boundary have something like free will, source of action? And in the Baron-Dieron work, they suggest making use of causal mechanisms to attribute source of action to these kinds of systems. In a nearby paper by Zach Henton and colleagues called Discovering Agents, very cool paper, they explore the use of causal models as a way of attributing something like this notion of a source of action to different subsystems within a world. So here we have a little mouse in a grid world, and what they propose is to invoke a particular causal model to inspect some pieces of that causal model to determine whether or not the mouse is the source of action, not something else, cheese. And what Henton and all say in a footnote is that the choice of the causal variables that go into this causal model effectively represent a reference frame that dictates whether or not you will find that this mouse is something like the source of action. In other words, when we draw a causal model that represents this setup, there's a choice of a different frame. Depending on what choice we make, we'll reach a different conclusion as to whether or not the mouse is the meaningful source. This goes back to a lot of the old debates of free will that I think Henton and all did a really nice job of formalizing context of these causal models. In other words, source of action is very dependent. The next property is normativity or goal-directedness. There's a nice example from this really beautiful book, Games, Agency with Quinn. in which you can imagine someone playing a game like this gentleman here playing chess. And you can think, what are the goals that's driving this gentleman while playing chess? Perhaps he's here to have fun. Perhaps he's here just to win, be the best possible chess player he can be, or perhaps he just likes to socialize and play with other players. Arguably, these could all be meaningful explanations of this gentleman's behavior while playing chess, but it's not so clear. So in the context of RL, this connects quite nicely to these older results on the unidentifiability problem in inverse RL. So going back to the column in the 60s, we have this problem that if you're given a policy of an input-output system, and you'd like to find a reward function that explains that policy, that is, can be said to be the goal of that policy, in the sense that it solves this little optimization problem, the difficulty is that the zero reward function is always an explainer of these policies, right? It's consistent with every possible policy that policy could have been found by maximizing the zero or constant. And in addition to this reward function, there are many such other reward functions that are explanations in a way of these policies. In other words, every policy is consistent with many reward functions. And so what this leaves us with is the choice, how to pick from among these different reward functions, or perhaps a meta principle, and delineate between these reward functions. So which ones give rise to a meaningfully goal-directed policy, and which ones you're left out in terms of meaningful goal-directedness. So coming back to our gentleman playing chess, what this might look like is to invoke different meta principles that go into the choice of meaningful. So Armstrong et al. Make use of, say, Occam's razor for isolating what rewards or explanations count as meaningful. Siebert et al. Use things like max entropy. And according to these different choices of meta principles, you will reach different conclusions about different subsystems as to whether or not they're meaningful. So these meta principles, for us, provide the reference frame in the context of something like attribution and normativity. So the last property is adaptivity. This goes back to an old paper by Zada in the 60s. Called On the Definition of Adaptivity. In this, Sade says all systems are adaptive. It's just a question of what they're adaptive to and to what extent. So building on this premise, we can imagine a little simple example involving two states and two actions. We can imagine a simple stationary policy that takes the blue action on the left and the red action on the right. So this policy is really just alternating between these two actions, taking blue, then red, and blue, then red. We can ask the question, can we think of this policy as adaptive or not? And again, as Ade suggests, it's frame dependent. So what this would look like is that according to one commitment as to what meaningful change in behavior looks like, you might say any change in action should count as adaptivity. So in this case, switching from blue to red counts as meaningful change and therefore counts as an adaptive system. However, according to a different commitment as to what meaningful change in behavior looks like, you might require that the policy update its assignment of action at a first state level, and therefore you would conclude that this policy is not adaptive. So collectively, we say adaptivity is frame dependent alongside these other properties, and therefore agency is frame dependent. So just wrapping up, one of the main motivations for working on this is to really embrace agency as a first principle amongst the community. There's a lovely book, Evolution of Agency by Tomasello, which he closes by saying that every scientific discipline has a proper domain or a first principle. In biology, this proper domain is something like life, and in psychology, depending on theoretical predilections, proper domain might be either behavior or mentality. But my preferred candidate would be agency, precisely because agency is the organizational framework within which both behavior and mental processes operate. And I agree with this claim, and I want to fully embrace this and really take agency as among our first principles. So just as a reminder, the structure of the argument went, we want to ask, does a particular system have agency? We pick a boundary, subject to that boundary, we then make a deliberation about each of these three properties, and in doing so, we have to bring on board this notion of a reference frame. That leads us to this conclusion, agency is frame. There's a bunch of open questions here. As part of this, we would love to come up with a mathematical formalism for reference frame that can be a starting point for modeling and thinking clearly about agents alongside, say, things like Markov decision processes. And similarly, we'd love to look at meta principles for actually choosing reference frames. And we kind of elevate some as being consistent or coherent or aligning with our intuitions about what we find in the natural world, and maybe show some are inconsistent. Ill formed reference points. As a quick advertisement, if you're curious about this kind of work, this group has just put out another paper in a very similar vein. Just goes into a little bit more technical detail on these kinds of ideas. Be very happy to chat about those papers during the coffee break and beyond. That's all about. Thank you so much.